In this video, we have to understand the concept of how multi-master failover works. In previous sessions, we set up multi-master Kubernetes cluster where we use AK proxy for the load balancing purpose. So you can follow that video to set up the multi-master cluster. We use three master nodes, but we in those videos we have not understand the concept how different components of the control plane, that is ETCD, scheduler, controller, and your API, how those are working in the multi-master, how they are interacting with each other. So the core component, that is the ETCD, that is brain of our Kubernetes cluster, that knows everything about the cluster state, whatever API resources we are going to deploy in our cluster are saved in the ETCD database. So first we have to understand this ETCD database, how its cluster infrastructure will work. So if we take the backup of our ETCD, it means we take the backup of our Kubernetes cluster state. If we take the backup of ETCD, it does not mean we also take the backup of the applications running on our Kubernetes cluster. So backup of the application is a different thing that is related to the data saved in the persistent volume in the cluster for the relevant application. That is a different thing. But resource related backup, whatever what is running in the Kubernetes cluster, we can use etcd. So we will understand how does etcd cluster works. To understand the etcd, we should know about the Raft consensus. This is an election mechanism to select the leader by the members. So what is the process to calculate the ETCD quorum minimum required members? What are the minimum numbers of ETCD running instances are required to to elect their new leaders, to elect their leader? And why odd number of master nodes are best fit for the cluster? Why we cannot use the even number of master nodes? And then what is the split brain issue and how etcd is helping us, and how its structure is very powerful to handle the split brain issue. So we will use the node level of failure and we will use the etcd service level of failure to test our cluster, and we will use some client utility that is ETCDCTL for the ETCD database connectivity and check its health status. So let's start. I have Kubernetes cluster, and this time I set up the Kubernetes cluster with three master nodes. Why, well, sorry, four master nodes. Why four master nodes? Because normally we are using three or five or seven. But just to explain you here in the lab, I set up four. What is the why we are using four? So uh, what I did, I am running my HA proxy. This is the IP of my HA proxy, and here I can see all the master node states are healthy in the green state. All my master nodes are in good state, and etcd is running, API server is running. Okay, now just to query kubectl get pods. So let's see the etcd instances are running perfectly fine on all my master nodes. But the question is how they are interacting with each other. So for to understand this, I will run the command to connect with my etcd database, and it will give us the answer that either that the query we did to our etcd database is leader or not. It's a member, it's not a leader. And I query to the local host, and I am using master node directly to connect with my etcd. I can also use the IP. This is a straightforward command, etcd, and it is using this variable to know about the version of the etcd client. and I am using the CA certificate and private and public keys to connect with my ETCD database. And the port number of ETCD database is 2379. So I successfully connected and I get the information about this database. The endpoint status mean it's working fine. Its index ID is this. What version number it is using, what is the size of the database. Okay, I can also use, if I just do kubectl get nodes hyphen o white, so I can see this is my master node 1, this is my master node 2 IP, master node 3 and 4 IPs. So I can directly query to their IPs too. I just need this private key. This private key is working just like a password to interact with my nodes, etcd instances. So let me just try to all my master node. Second one is 5. Third one is 6. And fourth one is 107. So here you can see all three are members and one is acting as a leader. And 107, that is my master node 4, is acting as a leader. Okay, so I can use directly this command too to, to query all the etcd endpoint at once. So here what I defined the endpoints, all my endpoints, comma separated. So this machine can interact with all my etcd, and since the private and public key is replicated on all my master nodes, it's same for all the instances. So I can see the true value came for master node 4. It's acting as a leader. How it's acting, we will understand. So I am communicating with the cluster, like kubectl get pods or node I am doing. How it's communicating, for this we will just see the variable I declared for the kube config. It's the kube config file, and I'm just doing a cat to this file, and here I define the IP of my HA proxy to connect with the etcd. We understand this in detail in our previous video when we set up the multi-master cluster. So it's mean whenever I am queuing, I am going to my HA proxy, and HA proxy is connecting with the etcd. HA proxy is connecting with the API server. Okay, now we understand these two commands, and here I just ran the command like endpoint status. This was a single node and endpoint status, and it was multi-node endpoint status. Okay, let's now do some so some failover, and then we will understand what is the formula to calculate the minimum number of required quorum to elect its leader. So here I wrote the formula for the minimum number of required members. Uh, Total number of master nodes divided by 2 plus 1 is the formula. So the answer will give us the value that this is the minimum number of master nodes that should be up and running for the healthy state. This formula is actually for the ETCD. When we are talking about the master node minimum number required for the healthy cluster, it's mean the minimum number of ETCD. It's a requirement of the ETCD database. It's not the requirement of the API. It's not the requirement of the controller and scheduler. This is the requirement of ETCD. So if I have one ETCD, I calculated from 1 up to 10. So here we will understand Why odd number of master node are best fit? We will understand this, and we will also understand the minimum number of required. So if I have one master node, mean one ETCD, so 1 divided by 2 half plus 1, 1.5. So 0.5 we will ignore because half node does not make any sense. It's mean 1. So in case we have one ETCD, one master node, we need one up and running. Okay, it means zero failure in case of one master node. If we have two, 2 divided by 2 plus 1, 2. So we need two up and running minimum. In case of two, we also don't have any chance of losing our master node. In case of three, we have 2.5, it's mean two. Minimum two we need. It's mean we can lost one of our ETCD instance, one of our master node. In case of four, we need minimum three. We can lose only one. We can have a fault tolerance of only one master node. So now just focus here. In case of 3 and 4, we have one master node failure. In case of 5 of 6, we need here 3, we need here 4. We have two master node failure. Here in case of 6, we also have two master node failure. Okay. Similarly, for 7, 3 master node failure. In case of 8, 3 master node failure. In case of 9, 4 master node failure. In case of 10, 4 master node failure. So just focus. If we are using odd numbers and even numbers, the very next even number, we are getting the same number of failover nodes. So why we will use the 4 nodes? So we want to reduce our resource expenses. So that's why we will use the 3 because we are getting the one failure. Similarly, we will use the 5. We will not use 6 because we are getting 2 failure in 5 and 2 failure in 6. So this is the reason that 3, 5, 7 and 9 are the best fit for the maximum number of failover we can we can gain. So we understand now why odd number of master node are best fit, why not even, to make the best utilization of the resources. Okay, and we also understand this is the requirement of ETCD, not the requirement of API, not scheduler, not the controller. So now we understand minimum number of required members and the odd number reason. Let's start some failure, and we will start failure with the node level. So here I have kubectl get nodes. Let me just quickly check the health status. All are in healthy state, all API are up and running. And if API is up and running, it's mean ETCD is up and running. In the next video, we will understand why ETCD is a core component, why all are dependent on ETCD. So that's why I started with the ETCD hyphen o white. So I can communicate. So right now, if I run the same query again, all the nodes, and I know the master node 4, 107, is responsible for the ETCD instance that is elected as a leader. So I will just make the master node 4 settings. I am going to disconnect its network connectivity. It's mean it's down. Let's wait for a while and we will see here it's going to yellow and then it will turn into red. Mean it will be down. So now if I query to nodes, it will take a while because now election is happening and they are electing their new leader. So right now you can see first time I get the error. Now the state of the cluster is healthy because one of my API server goes down. Why API server goes down? Because of ETCD, because API server is closely interacting with the ETCD. If it goes down, API server will also lose its service. So we now have, if I just do the get pods, so it is still showing running, but it will be down after some time. And if I just run, if I query to my etcd database on all my master nodes, it will take some time to communicate with the error that which one is down. So now you can see the new leader elected by the remaining members is the master node 1. So we have 4 etcd instances, we have 4 master nodes. So according to this formula, we need minimum 3. We need minimum 3 nodes up and running. It means one failure. So one we lost. Let's we will fail one of another our etcd instance, or we can say the master node. So this time you can fail anyone. I will just fail master node 1 because it's selected as a leader, but this is not the reason. Uh, you can fail anyone. So just on the master node 1 network setting, I will disconnect its network connectivity. Just on the dashboard, we will see the master node 1 will also be down, and master node 2 and 3 will also be down because the minimum number of required etcd instances are not fulfilled. The rest of all will also go down. It will take a while. I think I can query if I just try to interact with the load balancer. I lost my connectivity from master node. So on the master node 2, let me just zoom in, and I don't think so I have this environment variable. Sorry, env. Yeah, I don't have. So I can use etcd Kubernetes admin.conf as a kubeconfig, and kubectl get nodes, and our etcd will not respond by the load balancer. So just wait for a while. You can see now master node 2 also lose its connectivity because minimum number of required members are not met successfully. You can see here green up and down in 2 and 3 because they are connected with the network. 4 and 1 lost the connectivity. You can see here sometime green and again yellow and red, green, because etcd is trying to connect with the API server is trying to connect with the etcd, and whenever it will not be able to connect, it will restart its service. When the service will restart, it will again turn to green. Then when the service of the API will start, It will be green and it will again try to connect with etcd, again it will fail. So this cycle will continue. It will come up and down, up and down. So, but this is not the healthy state. Even the API server is green, but you cannot query for any cluster resource, because the answer of this question is because let me just run this command now from this master node to to check the health of my nodes. So 101 I am going to remove. So here you can see the first one should be up and running, the first one in the line I defined. So here you can see 107 is not responding. 5 and 6 are up, but they are not leader, they are member. And why they cannot make an election? Because of the minimum number of required uh, uh, for the election quorum. Okay, so now here another question can be in the mind, that how they know that the minimum they are the minimum, how many nodes they were before. So I can use another query, the member list. Okay, so on any of the node I can query mean how many nodes were actually working in the cluster since we lost them. So I query, and the acting one nodes responded, they were 4. It is saved in the etcd database that they were in fact 4, but right now this another query endpoint status shows us that only 2 left. So that's why they cannot make a new election and there is no more leader. So I have 4 master nodes, but I can lose only one master node. So no benefit of you running 4 master nodes. 3 master nodes are best fit, because in the 3 I will also be able to lose only one failover for the master node. And in fact, it's the reason behind is the ETCD database. This is the requirement of the ETCD database, and this is the requirement of the this Raft consensus algorithm used by the ETCD election process. So I hope we so far understand how ETCD cluster works. With the failover, we just did node level failure. How to calculate the members for the election, why odd numbers are mandatory. Now, what is split brain issue? The split brain issue is something like, think like you have multiple master nodes and they are connected with the physical network switches, and they are separated because of some network connectivity. I mean, master node 1, 2 can communicate with each other, and 3, 4 can communicate with each other. But 1, 2 cannot communicate with 3, 4, and 3, 4 cannot communicate with 1, 2. And they are now in running in isolated mode. And they will try to elect again. I mean, this can be a different quantity. I just gave example of the 4. Think like think like we have 10 master nodes. So if we divide 10 into different isolated networks, five can communicate with each other and other five can communicate with each other. Can they elect their new leader independently? Is there any chance that there can be two leaders in the different isolated same cluster because of the network disconnectivity issue? The answer is no, because the minimum healthy numbers of ETCD and master nodes are six. Five are on one side, five on one side, they cannot choose. Okay, now think again, not about five or five, just like six and four. They are isolated because of some network issue in the physical environment. So six one side will win, they can do the election and they can choose their leader and the cluster will be up and running. The remaining four will remain passive, just like the state is here. The two, they are thinking about the election, but they cannot do because they are only two. They need at least third one to choose the leader. So let me just quickly move back my master node 1 with the network connectivity and let's see what happened. So network is going to connect for master node 1 and just wait for a while. We will see the whatever three are, they will make the election. Let me just run this command again with all four. So now you can see the when first one came back, again election happened and master node 2 become the leader. So the split brain issue cannot be happen. Think like any number like for example we have 48 master nodes. Just randomly I am calculating. 48 plus 1. So half of the 48 is 24 plus 1, 23. We need 23. So think like you have 48 master nodes. This will not happen in the practical life. No one will use the 48 master nodes, but just a random number I chosen to give you the example. So think like 48 we have, and now you think if there is a split brain happen, they are independently divided into different groups. Some are in 10, 10 are, can communicate with each other, remaining 20 can communicate with each other, and remaining of 18 can communicate with each other. Just let me write divide it here like 10 and are isolated plus 20 are isolated, 30 plus 18, it's 48. Okay, so the minimum number is 23. They cannot elect. 18 cannot elect, 20 cannot elect, and 10 cannot elect. There will be no leader. Okay, let's divide them with some bigger value. Like on one side, there are 30, and remaining all are here 18. Okay, 30 plus 18 is 48. So 30 can choose their leader, and they will be in the healthy state and the ETCD will work fine, but 18 will remain passive. So it is impossible of the split brain issue that there are some different groups of ETCD and master nodes and they elected their own leader and there are two leader in a single cluster. Just you can do your own calculation of any type and let me know if you found uh, any number that can cause a split brain issue. So this formula will not help, will only be able to elect the split brain case only one leader. So we discuss all these concepts: ETCD, selection, odd number, the even numbers are wasted of resources we can use, just like I did. It's the split brain we understand, and we did node level failure. So let quickly bring back all the nodes back to work. I think the master node 4 I disconnected. I will connect it back with the network, and I will again query. Remember, with this query, the first one should be healthy. Otherwise, this query will fail. So now all are in healthy state. Okay, and they are interacting with each other. And 2379 port is for the end user connectivity with the ETCD, and 2380. If I just do a netstat, and netstat command is not here on master node 2. Master node 1, let me just let run it, connect quickly. Okay, I'm connected with master node 1, and all the nodes are in healthy state. So if I run net stat tup pipeline grep etcd. So etcd is running over on 2379 and 2378. So 2378, yeah, 2380, not 78, 2380. So ETCD is using two ports, 2380 and 2379. 79 is used for the connectivity by the other components who want to communicate with the ETCD database, like API server, like us, like human, we are communicating by using the ETCDCTL utility. And 2380 is used for the intercommunication of their ETCD databases, so that anyone get the new value, the leader will actually get the new value, and it will propagate the data to rest of the members. And it is also used for the election process. So now we understand this. Now let's just do the final thing, lab with ETCD level failure. So here all my nodes are healthy. On master node, ETCD is running as a static pod, and if you are confused about static pod, you can go through with the previous videos. Manifest, and I'm just moving this static pod to removing the static pod, and you will see here that one of my instance is shown as down, because I shut down one of my etcd instance. Okay, and now if I query again to look into the health of sorry, not here, I did this master node 2. So I told you that the first one should be healthy state. 101 is down. I'm just removing, or just I can change the sequence. 101 at the end I will query, and healthy one I will query first. 107. Let's see. You can see one of 101 is down, remaining are working fine. because I shut down ETCD from the pod level. Node is working fine. So here master node 4 is showing down state. It is back to work because of the failure for a while. And if I shut down, for example, this time I will not shut down the leader, I will shut down the follower 107 from anyone I can do. So here from etcd Kubernetes manifest and just move this etcd's manifest file under the temp, and as soon this etcd will shut down, we will notice here it will take a while to shut down the etcd, and we can query here this time 107. I will not use, I'll use its 5 and change the 5 with 7 because I know the 107 is down. Let's query. We will see only 2 will remain as a member. The leader will be false. They cannot elect. Nodes are healthy, but etcd is down. So since all the API servers are happy and they are trying to communicate with the leader, but after some time we will notice here the etcd will be down. It will take some time because it's not a node level failure, but if we try to query, just quickly, if I run ctl get nodes, it will not respond us because etcd, we are talking with the etcd and etcd is asking the information from, sorry, we are talking with the api and API is asking the information about the nodes from etcd and etcd is not responding. So you see here 2 are down because they are timeout. They retry to etcd, the API server, and they retry and failed and again started. So you will see, you can see here the status. It will come yellow, green, red, yellow, green, red. But even though they all are green, it will not help us because this because the on the backend database server is down. So how we can, uh, if the etcd is up, normally we are thinking that our cluster is healthy, but this is not the case. So in the next video we today understand these 4 points along with this lab and these commands. In the next video I am going to explain you about the API details. On these 2 points we will discuss and we will do the lab and we will understand the interaction with the API, and we will also do the video related to scheduler and controller manager, how they are working, and then the concept of MTLS, mutual transport layer security. So this was the first part. I hope you got the idea. So let me just again bring back my cluster back to work, and so that in the next video we can follow. So cannot query to the etcd, and right now this is the state, and we have to move back the etcd manifest to this location, and on this node we did this mv/temp etcd to this location. It will take a minute to run the pods again, And when the pods will be back, the Raft consensus will happen and a new leader will be elected, and then API server will do its retry, and on one retry it will be successful with the connectivity with the leader. So now you can see my three API server are back to work, and if we query to my same query I'm going to run, and here we can see all the etcd instances are up, but still one etcd was confused, so there is a retry timeout, and there is a prop health prop set up in the etcd pod that will retry to connect with the database. So now all the etcd are back to work, and they will remain until they can communicate with the leader. So now this command is giving us the real state. So you should run this command instead of just querying to etcd to get the real-time state of the cluster. If your etcd is healthy, rest of all you can troubleshoot. So now three are member, one is leader, that is master node 1. So we will do upload the new video, the next video for etcd and then for the scheduler and controller.